question. Both of you answer it in different way, but it's exactly the same. It's a way for us to filter signal. So how you can build a filtering a signal if you don't know what frequency it is operating on. So that's the first thing. And as you said, as some of you said already now, like it's a way to know how much of the spectrum you are using. How much? So because like every component of this signal you are sending in the frequency in the time, you can see it in the frequency domain, and you see how much spectrum. And as I explained before, the spectrum and the frequency spectrum is limited resources. So I cannot really allow you to send whatever bandwidth you use, because otherwise you will block everyone else. And so we need to do this let's say selection, the selectivity of the signal. You can do it in the frequency domain. And since you can also filter it, so you can control it also. So if your bandwidth is, let's say, very big, you can still have a way to limit it to this. It doesn't go up. So if I give you 500 kilohertz of bandwidth, you can design your filter based on your frequency analysis, so it will not go above the 500K. And in that case, you will not affect anyone else. But that's important. That's really how much important, because without it, you don't have kind of way to select signals. So then without it, you cannot really do the whole communication system as we are working with it. It become everyone transmitting everywhere, because nobody know what's the difference. How I can distinguish your signal than mine if I cannot see them in the frequency domain? Because in the time domain, they all elapse. Assume I will show it to you here. So I will show it in just like a sine wave, just because it's easy. So in sine wave, so you are sending this sine wave, and here at the beginning, they're sending this sine wave, right? Okay, of course, in the time domain, they will merge together. You have no idea. You cannot see them separately like this. They will be most probably like this. Something like that. Something in between. So you cannot really move them in the time domain. You cannot separate them in the time domain. But if you look at them in the frequency domain, this signal will be at this frequency because it's low frequency. So I call it FL. And this signal will go here in the high frequency, F high. And now you can see them at separate two signals. What we will do with them, just put a filter here, put a filter here, you construct them again back. And that's why if you cannot see them in the frequency domain, we will never be able to retrieve them, these two separate signals. And that's how very important the Fourier analysis and Fourier frequency domain. Now, of course, Fourier, to read in the frequency, that's something we are using now. But at the beginning, it was just analysis, a way to see the signal. Here, in this, I show you that's how you can really, using 3 tones, 3 sine waves only, to create a pulse, as a bulk, as some of you said. So if you have a single sine wave signal, it looks like that, right? It doesn't have any information. If you add another sine wave with other frequency to it, so sum it with the same sine wave but different frequency, you get some kind of figure like that. This is the summation of sine wave of omega t and sine wave of 3 omega t. If you sum 3 of them, of course, these are calculated like exactly in order to provide you with results. So it's not really random values. So If you have sine wave plus sine wave 3 omega plus sine wave 5 omega, you get your figure like that. So you can see it. It's become more and more similar to a a polk. Yeah. The time should be here equal for all of them. They are at the same time. Otherwise, it will shift. What it will create if they have different time? That's good. That's a good question. That's very good question actually. So now, for here, the time is equal, right? But now, if one of them has different time, exactly all of them the same, but one of them has different time, what will happen? I know you don't know. I'm just like want to to make it a way of more active. That's what happens. What we call it, the phase. That's how also we talk about here the phase of the signal. Ah, it's so far away. Yeah, this is the phase. We'll create it. If they have not the same time, that means there is phase shift occurs. What is phase? Always remember that because I will always say it. Phase is time multiplied by frequency. Time difference between two signals multiplied by the frequency, that's the phase. Always remember that from me. So this phase, as you can create it by just having different time. But if they are not really, there is no time difference between them. If there is no time difference, they are totally in sync, and you see it like that. If there is, there you have a phase shift between them, and that's something we will talk about. I'm not sure this semester or not, but anyway, that's another story. So you can see the beauty